Hello everybody, this is Mika Seppälä. In this lecture I talk about the absolute value. I define the concept of the absolute value and then discuss its properties. This is a very useful and central concept in calculus, and it is surprising how easy considerations can lead to difficult problems rather quickly. You will see just in a moment. The absolute value. Taking the absolute value of a number is an operation that converts a negative number to a positive number by changing the sign of the negative number in question. The absolute value of a positive number is the number itself. The absolute value of a number x is denoted by enclosing x in bars. So x surrounded by these bars is the absolute value of the number x, and it is x itself if x is non-negative, and it is negative of x if x is negative. This is the mathematical definition of the absolute value. Now for example, the absolute value of negative 5 is negative of negative 5, that is simply 5, and the absolute value of 2 is just 2 because 2 is a positive number. And if x minus 2 is non-negative, that is if x is greater than or equal to 2, then the absolute value of the expression x minus 2 is x minus 2 itself, otherwise it is negative of x minus 2, that is 2 minus x. And we have the following important property. A number x is always between a negative of its absolute value and its absolute value. In fact, here, depending on the fact whether x is positive or negative, we have equality on one side and strict inequality on the other side. Further, the absolute value of a number b is at most the absolute value of a number a. If b is between negative of the absolute value of a and the absolute value of a. These follow from the definition rather immediately. The absolute value has a geometric interpretation. Consider numbers x and y as being points on the number line. The distance between these points on the number line is the absolute value of the difference x minus y. For example, consider the problem of finding all those numbers whose combined distance from 1 and from negative 1 is 4. So the distance of a general point x from 1 is, by the above observation, the absolute value of x minus 1. And the distance of x from the point negative 1 is the absolute value of x minus negative 1. But x minus negative 1 is just x plus 1. Therefore, these numbers x satisfy the absolute value of x minus 1, that is the distance of x from 1, plus the absolute value of x plus 1 equals 4. Here the absolute value of x plus 1 is the same as the absolute value of x minus 1. So we have to solve this equation. Solving this equation first involves getting rid of the absolute value signs. And this can be done by limiting x into certain intervals. We do it in the following way. First we observe that if x is greater than or equal to 1, then both x minus 1 and x plus 1 are non-negative. Therefore, if x is greater than or equal to 1, the absolute value of x minus 1 is x minus 1 itself, and the absolute value of x plus 1 is x plus 1 itself. This means that if x is greater than or equal to 1, the left-hand side of the above equation, that is the expression the absolute value of x minus 1 plus the absolute value of x plus 1, becomes simply x minus 1 plus x plus 1. Negative 1 and 1 cancel out, so we get just 2 times x. And this computation means that if x is greater than or equal to 1, this original equation that we have to solve reduces to the equation 2 times x equals 4. But if 2 times x equals 4, then x equals 2. Now this number 2 is larger than 1, therefore it belongs to this interval x greater than or equal to 1, and this means that x equals 2 is a solution. Next we have to consider the situation where x is between -1 and 1, -1 allowed, 1 not allowed. If x is between -1 and 1, then x minus 1 is negative and x plus 1 is non-negative. And this means that the absolute value of x minus 1 is negative of x minus 1, and the absolute value of x plus 1 is x plus 1 itself. And the left-hand side of this equation reduces to 1 minus x plus 1, and that is simply 2. Therefore, if x is between -1 and 1, the equation reduces to 2 equals 4, but this is of course always false because 2 is not 4. And this means that there are no solutions between -1 and 1. We still have to consider the situation that x is less than -1. Then x minus 1 and x plus 1 are both negative, and this means that the absolute value of x minus 1 is minus x minus 1, and the absolute value of x plus 1 is also minus x plus 1. And the left-hand side of this equation becomes 1 minus x minus 1. Just plug in the values. And 1 and minus 1 cancel out, so the left-hand side becomes -2 times x, and the equation itself is -2 times x equals 4. And this if x is less than -1. And the solution to this is x is -2, and since -2 is less than -1, this means that x equals -2 is a solution. So our original problem was to find all numbers x whose combined distance from 1 and from -1 is 4. And we have computed all the cases, and we have found out that the solutions to this equation, absolute value of x minus 1 plus the absolute value of x plus 1 equals 4, are x equals 2 and x equals -2. Now this can be also seen geometrically. These points -1 and 1 are now drawn on the number line. They are the blue points. The white point is the origin in between. The points x whose combined distance from these two blue points is 4. They are clearly the points x equals -2 and x equals 2. This is of course obvious for geometric reasons. The triangle inequality is an important tool in calculus that has applications to almost all areas of mathematics. We start by observing that if A, B, and C denote a length of sides of a triangle as the one shown here in this picture, then C is always at most A plus B. In fact, C is strictly less than A plus B if this triangle has a positive area. That is, if this is a proper triangle as the one shown here. If the triangle reduces to an interval, then of course C equals A plus B. But that is a certain special limiting case. For numbers x and y, we have a version of this triangle inequality, and it says that the absolute value of x plus y is always between the absolute value of x plus the absolute value of y, and the absolute value of the difference, the absolute value of x, minus the absolute value of y. This is the triangle inequality, and of this we most often use the right-hand side inequality. Next, I want to justify why this is always true. So I start with a claim. The absolute value of x plus y is at most the absolute value of x plus the absolute value of y, and at least the absolute value of the difference, the absolute value of x minus the absolute value of y. And I first prove the right-hand side of this triangle inequality. And to that end, I observe that for any numbers x and y, we always have that these numbers are between negative of their absolute value and their absolute value. And depending on whether the numbers are positive or negative, we have equality on one side and inequality on the other side of this double inequality shown here. So clearly we have minus the absolute value of x is at most x, and this is at most the absolute value of x, and same for y. And adding these two double inequalities together, we get that minus the absolute value of x plus the absolute value of y is at most x plus y, and that is at most the absolute value of x plus the absolute value of y. But this means that the absolute value of x plus y is at most the absolute value of x plus the absolute value of y by the properties of the absolute value. So this follows simply by adding these two inequalities that concern the absolute value of x and the absolute value of y. And this also proves the right-hand side of this triangle inequality. So we now know that the right-hand side of the triangle inequality is true, that is, the absolute value of x plus y is at most the absolute value of x plus the absolute value of y for all numbers x and y. We use this fact to justify also the left-hand side. In order to do that, we set x to be a plus b and y to be negative of b for some numbers a and b. Then, since we know that the absolute value of x plus y is at most the absolute value of x plus the absolute value of y, we plug in place of x a plus b and in place of y negative of b. Then x plus y is a plus b minus b, that is simply a. So the absolute value of x plus y becomes the absolute value of a after this substitution. And the absolute value of x is the absolute value of a plus b, and the absolute value of y is the absolute value of negative of b, which is the same as the absolute value of b. This means that the absolute value of a plus b is greater than or equal to the difference absolute value of a minus the absolute value of b. So this is what we now have. The absolute value of a minus the absolute value of b is at most the absolute value of a plus b. Next, we apply the same reasoning to the numbers x equals a plus b and y equals negative of a. So we simply exchange the roles of a and b in this argument. We get precisely in the same way that the absolute value of b minus the absolute value of a is at most the absolute value of a plus b. Therefore, the absolute value of a plus b is both larger than or equal to the absolute value of a minus the absolute value of b and negative of that. This means that the absolute value of a plus b is greater than or equal to the absolute value of the difference, the absolute value of a minus the absolute value of b. And this is the left-hand side of the triangle inequality for numbers a and b. And of course, since this is true for all numbers a and b, it is also true for all numbers x and y. That is, the triangle inequality is now shown to be true. The triangle inequality says that the absolute value of x plus y is always between the absolute value of x plus the absolute value of y and the absolute value of x minus the absolute value of y. This seems rather technical, but it really all boils down to the fact that the length of two sides in a triangle is more than the length of the third side. That is, in this picture, a plus b is larger than or equal to c, regardless what triangle we have. Here are the properties of the absolute value. First, the absolute value of any number a is always a non-negative. It is 0 if a is 0 itself, and otherwise the absolute value of a is positive. The absolute value of negative of a is same as the absolute value of a. The absolute value of a squared is same as a squared itself. A squared is always non-negative. The absolute value of a product a times b is the product of the absolute values, the absolute value of a times the absolute value of b. And a number a is always between a negative of its absolute value and its absolute value. And here, depending whether a is positive or negative, we have equality on one side and strict inequality on the other. Let b be a positive number. The absolute value of a is larger than b if a is larger than b itself or less than a negative of b. Seventh property says that the absolute value of a equals the absolute value of b if and only if a is either b or negative of b. And the eighth property is the triangle inequality. The absolute value of a plus b is always between the absolute value of a plus the absolute value of b and the absolute value of the difference, the absolute value of a minus the absolute value of b. This is the most important property of the absolute value function. As an example of the use of the triangle inequality, let us show that for all numbers x, y, and w, the absolute value of x minus y is always at most the absolute value of x minus w plus the absolute value of w minus y. How does this follow from the triangle inequality? We first observe that x minus y is x minus w plus w minus y. Here we have simply subtracted w and added w. This means that we have not changed anything. So the absolute value of x minus y is the same as the absolute value of x minus w plus w minus y. Next, we use triangle inequality to this expression, with x minus w being the x in the triangle inequality and w minus y being the y in the triangle inequality. So we observe that by the triangle inequality, this is at most the absolute value of x minus w plus the absolute value of w minus y. And we have shown what we were supposed to show. Now my question to you is, when do we have equality here instead of inequality? This is a puzzle, you may think. In this example, we solve the absolute value equation. The absolute value of 2 times x plus 1 equals 5. And we do that by using the properties of the absolute value. The absolute value of a number is some other number, in this case 5, if and only if that number is either 5 or negative of 5. That is, the equation absolute value of 2 times x plus 1 equals 5 is equivalent to saying that either 2 times x plus 1 equals 5 or 2 times x plus 1 equals negative of 5. In both cases, the absolute value equation is valid. So now we solve these two equations. 2 times x plus 1 equals 5. This means that 2 times x equals 4. And this means that x equals 2. This is a solution. 2 times x plus 1 equals negative 5. This means that 2 times x equals negative 6. And this means that x equals negative 3. And this is also a solution. So the answer is that solutions to this equation, the absolute value of 2 times x plus 1 equals 5, are x equals 2 or x equals negative of 3. In this example, we solve the absolute value inequality. Absolute value of 2 times x plus 3 is strictly larger than 5. And here again, by properties of the absolute values, this absolute value inequality, absolute value of 2 times x plus 3 is larger than 5, is equivalent to saying that either 2 times x plus 3 is larger than 5 or it is less than negative of 5. The first equation tells us that 2 times x is larger than 2, and this means that x is larger than 1. So all numbers x larger than 1 are solutions to this inequality. The second equation tells us that 2 times x is less than minus 8, and this means that x is less than negative 4, and all these numbers are solutions as well. So we conclude that the answer is numbers x for which the absolute value of 2 times x plus 3 is strictly larger than 5 are the numbers which are either strictly larger than 1 or less than negative 4. Our task in this problem is to sketch the graph of the equation x plus the absolute value of x equals y plus the absolute value of y. So our task is to find all the points x, y satisfying this equation. So we have to solve the equation. If x and y are both non-negative, then their absolute values are the numbers themselves. Then the equation x plus the absolute value of x equals y plus the absolute value of y reduces to 2 times x equals 2 times y, and this means that y equals x. So in the first quadrant, that is when x and y are both non-negative, the solution is the line y equals x. In the second quadrant, that is if x is less than 0 and y is greater than or equal to 0, the absolute value of x is negative of the absolute value of x, and x plus the absolute value of x is 0. And therefore, in this second quadrant, the equation reduces to 0 equals 2 times y, so this means y equals 0, and this also means that there are no solutions in the second quadrant except for the origin, which may be viewed as being a point also in the second quadrant. In the third quadrant, both x and y are negative, and the absolute value of x is negative of x, and the absolute value of y is negative of y. Therefore, x plus the absolute value of x and y plus the absolute value of y are both 0 when x is negative and y is negative as well. This means the equation in the third quadrant reduces to 0 equals 0. This equation is always true. This means that all points in the third quadrant are solutions. In the fourth quadrant, x is greater than or equal to 0 and y is less than 0. Then the absolute value of x is the x itself, and the absolute value of y is negative of y. This means y plus the absolute value of y is 0, and the equation reduces to 2 times x equals 0. The solution to this equation is x equals 0, and therefore there are no solutions in the fourth quadrant. And we summarize this that in the first quadrant the solutions are the line y equals x, and in the third quadrant all points are solutions, and so the graph of this equation x plus the absolute value of x equals y plus the absolute value of y is the blue graph shown here on the right. We conclude this presentation by summarizing the properties of the absolute value. First of all, the absolute value of any number is always non-negative. The absolute value of negative of a is same as the absolute value of a. The absolute value of a squared is same as a squared. The absolute value of a times b is the absolute value of a times the absolute value of b. A is always between negative of its absolute value and its absolute value, and if b is positive, then the absolute value of a is larger than b if and only if a is either larger than b or less than negative of b. The absolute value of a equals the absolute value of b if and only if a is either b or negative of b, and then finally the triangle inequality. The absolute value of a plus b is at most the absolute value of a plus the absolute value of b. The left-hand side of this triangle inequality is less used. The right-hand side is the most important.